Good afternoon. Today we are going to see the Ericsson RBS 6000 series. We will see the physical looks of this RBS. Coming to the inside of the RBS, this is a universal cabinet. We can use any plug-in cards on this, but from overall, we will see from the top. We will start from the top. It is RBS 6000. We will see that there are fans working, which are used for the cooling purpose. Their fan cables are connected to here on the SCU card. This is the top of the SCU card, which is this card, SCU Support Control Unit. This is the model SCU 0301, and this card is SHU Support Hub Unit. This is used to connect all the digital units to this SCU so that temperature can be controlled by the SCU. So coming to the this power cables, DC main power cables. This is a 54 volt, 48 volt requirement. 54 volt is optimal voltage and 48 volt is the minimum required for the good working of the RBS. 0 volt is this side and minus 48 volt is this side, and this DC cables are feeding power to this bus bar on the end. We can see from there to there, and two PDUs are connected on this bus bar. This is PDU number 1, PDU number 0. Its model is PDU 0201, and this is the product number. This PDU has around 11 physical ports on this. Each port can be connected one power supply, like this SCU is connected to PDU port number 7, and two DUGs. DUG means digital unit for GSM. This DUG is taking power from PDU port number 1 and PDU port number 3. It should be here, but anyways, we will carry on with our work. This DUG has ports for GPS and environment control, LMT ports for the local connection, ETA port for the E1 connection, and then the CPRI cables, CPRI ports for whatever number of the RUSs are to be connected. For this specific site, we have two DUGs, and there is GPS sync supposed to be taken by the DOW. But anyways, if we are using GPS sync or NGS sync, it will be here, we can see. And coming from the top, this is cable for environment control, and we have ETA cable. This ETA cable is connected to the TCU. This is our TCU unit. TCU supports transport control unit. These two cables are connected to two separate DUGs. This cable is for the 3G DOW, and this is the main hub unit, hub cable, uplink cable, which is connected to the Jeppon device. This in the bottom we can see this is our Jeppon device. From here, this is a Huawei Jeppon, and coming to the top, this RBS is a universal RBS. We can put radio unit for multi-standard like RUS here, RUW, something like anything, whatever is required for the RBS. This is a universal RBS. Anything can be fit in here. But on this side we have RRUs, no RUS, and with these CPRI cables, these fiber cables are connected to the RRUs. We will later on see the physical RRUs also. Coming down on the DOW means digital unit for WCDMA, and it has similar ports, like first top port is for GPS. If GPS sync is supposed to be taken from the DOW, this cable should be connected here. The DOW can give the sync to the GPS sync to the DUG. This cable is for the transport TNA, which is connected at this TCU, which we before seen. TNA, and coming down to this, because these two DOWs work in primary secondary scenario, so one DOW should be primary and second DOW should be secondary. And this is also a sync cable, F2F sync, and this port is ideal. We say it a ideal cable and F2F cable, and all these three are RRUs. These three are also RRUs. This means that this is a 6-sector site as well for the 2G and for the 3G. On this specific site, DUG and DOW both are working as in the sync form. Like we can say that one RRU is working in mixed mode for 2G and 3G both. So coming down in the RBS, This is the transport control unit TCU, which we have seen before. It has one power port and LMT port for the local connection with the 192.168.1.1 IP, and then GPS port, then E1 ports. These 4 are E1 ports. Then these 4 are the electrical Ethernet ports, and there are then 4 ports for the optical Ethernet ports. Then coming down to this R503 multiplexer. Now, before seeing this multiplexer better, if we take a look at the baseband, this is a FDD baseband. This side is only 2G 900, 3G 900 and FDD 1800. This FDD 1800 baseband is a kind of latest model 6630. We can see its product number and model number. It has ports for alarms on the baseband as well, and there are ports for LMT local connection and ECE connection, and for if there is any SAU side alarm unit, it can be also connected. The cable can also be connected here, and there are sync ports. If it needs sync from the GPS directly, it can be connected here, because we are using this baseband for the TDDs also. So these ports are universal whether we use it or not. These baseband have, all basebands have these ports. If this was a TDD needs direct real-time GPS, so there should be a GPS cable from GPS module which is to be connected with the GPS antenna. So this coming back to this transmission cable, this is TNC cable. Every baseband have 2 ports for electrical and 2 ports for the optical. This is like, if there is SFP port, we will use this one. If there is electrical, we will use this one. So the ports start from that side. We will see again. Port A, B, C. If you guys see again, port A, B, C, D, E, F. These are like FDD 1800 cells. A, B, C, D, E, F. These all are 1800 cells. Since this is a site with too many sector requirements, actually this is an IBS site. It needs much more sectors. So there are 6 fibers which are connected to 6 different RRUs, and then these cables are going to LMN, are going to the multiplexer unit. These cables connect here. Like L cable is supposed to be connected at port number 3, and M cable is supposed to be connected at port number 2, and N cable is supposed to be connected on port number 1. This multiplexer starts cable number 1 is here, 1, 2 and 3 in this form. And if we say that this is just a multiplexer, internal cross connects are there, only cross connections. This multiplexer is not an intelligent unit. It takes all its configuration from the main baseband. We say that from port number 3 up to port number 7, this is internally cascade, internally like connected ports. Whatever comes in this port goes to these ports, and whatever comes on this port is internally connected to these ports, and whatever is connected on this port is internally connected to this port. So sector number 1 should be here, 2 and 3, and in this same form sector 1 is this, and this is sector 2, and this is sector 3. So this is the kind of complex things in this multiplexer. We will later on see this further, and if you guys have any question, you can ask me in the comment section, and I will try to answer these comments. Also, if you like this video and you need more videos, you can inform me, and I will try to make more similar videos. I see that this is PDO 0, which I explained to you, but this is also a similar PDO 1 there, because there were scenarios when there were too much RUSs filled in this cabinet, and we required too much ports, so there was a second PDO. But now, because this site is a modernized site, there were activities done and RUSs were removed, and only RRUs are connected to this site. So I will pause the video. I will move to the RRU section. Okay guys, this is our RRU. This is the RRU for 900 technology, and similar, this one is RRU for L700 technology. And coming down to the bottom to see that how these are connected, this one is 900, and this one is L700, and this one is 1800, and this one is FTD 2100. If we go down, we can see that each RUS has its own product number. It like all looks same, but they are working for separate technologies. So this one is the RRU, which is 2212B1. Like this is FTD 21. B100 means that this is 2100 megahertz. In the same way, we can see this one as this is B3. This means that B3 is 1800 megahertz. It has only one jumper cable and one fiber cable and one power cable and grounding cable, and in same way this is one fiber cable, power cable and jumper cable and grounding cable. Because there is no requirement for all the jumper ports, so only one jumper ports are used. And we can see that this one is the RRU for P28. L700 is product number is for B28, 700 megahertz. It has one jumper cable, one power cable, one fiber cable and one grounding cable. So in the same farm, we discussed before that the 900 megahertz RRU have two different technologies connected here. This is B8. This cable is connected to the W900 3G, and this cable is connected with the 2G. Okay, very good. This is open, but we need to tighten it. This is like a 2G cable, 2G fiber cable, CPRI cable, and this is 3G CPRI cable. It has two jumper cables connected here and one power cable and one grounding cable. So this is it for today's video. If you guys have any question, you can ask in the comments and I will try to answer.